In this video, we'll discuss the future and present value of an annuity. So before we actually get to computing those values, let's first talk about what an annuity actually is and how we can represent an annuity mathematically. So we're studying annuities, and an annuity is defined as simply a sequence of equal payments made at equal periods of time. And so two common or popular uses of an annuity is either to accumulate funds for some future goal. For example, maybe you want to purchase a car or a home in the future. Or it could be to withdraw funds from some kind of account. Maybe it's a retirement account, or it's some lump sum of money that you've received and you want to receive equal payments from that amount. Okay? What we mean by ordinary annuity, which is what we'll spend most of our time dealing with, ordinary means that payments are made at the end of the time period. That's important. And the frequency of payments is the same as the frequency of compounding. So if you have an account that compounds twice per year, then you're going to make two payments per year. Okay? So that's what we mean by an ordinary annuity. And we'll study ordinary annuities in much more detail. Now, before we get into the details of computing annuities, I'd like to talk a little bit about the two main values associated with an annuity, just like the two main values associated with compound interest. And that is the future value and the present value. Okay? These are the two main areas we'll be interested in, two main ideas. Well, future value, just like it says, is the value you expect in the future. So again, an annuity is simply an account in which you're putting equal payments at equal amounts of time, right? And it's earning some kind of fixed interest that you know about ahead of time. And so if you know all of that information, the future value is the amount of money that you would expect in the account at the end of some period of time. If you are inserting a certain amount of money, a fixed amount, in this account at equal intervals. Okay, that's what future value means, and we'll come up with an actual formula for computing that. And the other thing we're going to talk about is present value. Okay, and present value is exactly what it says as well, which is it's the value the annuity is worth in present day dollars. In other words, how much it's worth right now, knowing that the interest you will earn in the future. Okay, so in other words, the point is that the present value is how much the annuity is worth right now, given that you're going to be putting money into this account, earning a certain amount of interest. Okay, and again, this is associated with the time value of money, because certainly money is worth something. So not only are you going to earn interest on this money as time goes on, but you're also have to think about inflation as well, which is associated with interest rate. So again, the present value is how much the annuity in some X amount of years is worth in today's dollars, knowing that you're going to put money into this account throughout some amount of time periods. Okay, so that's what we mean by present value. And we'll get into the specifics of both of these in more detail. But this is the general overview of what we're going to talk about dealing with annuities. That is the future value and the present value. One more note about the relationship between the present value and the future value of some given annuity. We almost always have this relationship. That is, the present value is almost always less than or equal to the future value. And that makes sense because of this thing called the time value of money. That is that if we're talking about the future value of some kind of set annuity, right, we're making equal payments and we're earning interest on those payments. And so let's say we're talking about some kind of annuity that lasts for 20 years. Well, we're earning interest over that 20-year time period on these equal payments. And so in general, since we're earning interest, the future value is going to be worth more than the value it's worth right now at the start. Okay? And again, that's because of this time value of money. Money's worth more money as time goes on because you can earn interest on it. And so in general, the present value will be worth less than the future value. Okay? And we'll compute both of these values. We'll come up with some actual formulas for both of them. And we'll do some examples so you'll see what I'm talking about. In order to understand how we can mathematically model an annuity, we need to study a geometric sequence. So a geometric sequence is really just a sequence of numbers that all have a certain relationship. That is, that a geometric sequence is defined by this sequence of numbers, where A and R are both real numbers. Okay? So they all have this relationship, And you can write them in terms of bracket notation as just a collection of numbers, okay, for as long as you want to go, however many numbers you want. Each of them have this kind of relationship. And the first member in the sequence is this one. You start with A, then it's AR squared, and so on. Notice that the A is the same each time, and we're having higher and higher powers of R. In some sense, you could think of this as R to the 0 power, right? That's your 1. So we start with the 0, and we go on as far as we need to go. So the point is that because we start with A, the nth term in this sequence, this collection of numbers, is given by this, right? So it's AR to the n minus 1. It has power n minus 1 because we start with n equals 0. So we start with 0, counting that as the first term. So again, a sequence is simply a collection of numbers that are arranged in some kind of order. Okay, and this is the order, and this is the relationship among these numbers. Now, the thing to be careful is, even though we're going to use this geometric sequence to model annuities that have interest rates in them, this R is not the interest rate. Okay, be careful. The R actually means the common ratio, R for ratio, of the sequence. Okay, you can see there's an R that goes all the way through. And it turns out that the geometric sequence will be a very handy tool to be able to model annuities.